Good morning, ladies and gentlemen. Welcome back to the Extraordinary Technology Conference 2017. Today, it is my pleasure to introduce you to a first-time speaker here at our conference, Rhetta Jacobson. She'll be speaking on harnessing Vortexian mechanics. She advocates for a new and non-destructive technology based on the works of Russell Schauberger, Tesla, and Henry Fonda, rather than the explosion-based technology we use today. She publishes Energy Unlimited magazine and a newsletter called Causes. Her main purpose is to offer real solutions and real alternatives and she does so with Vortexian mechanics. Thank you very much. Please welcome Rhetta.
Okay. Thank you. Hello. Perhaps you've seen some of the videos that are on YouTube and at the University of Science and Philosophy's website about non-destructive technology based on implosion with the tools of the vortex. And a lot of the devices presented that are on those videos are 30 years old. They were on paper only at the time. So I thought I'd come and give an update. In 30 years, there was a lot of prototype devices built on the principles of Vortexian mechanics. We'll go through about eight different. Let me get the lighting just right here. Okay. Some of the pioneers of introducing the vortex started having the information come forward in the late 1800s and early 1900s. The light came around the world. And, I'm hitting the button, sorry. And various people started receiving this information and putting it forth. Walter Russell did an explanation of how wave mechanics form our universe and how wave mechanics are two vortice pairs coming together at amplitude from cathode to anode and making all the electromagnetic phenomena in our universe. He has beautiful illustrations in his book, The Universal One, and other books that are for sale at the table back here if you'd like to take a look. And I thank the university for sponsoring me to get here. And of course, Victor Schauberger, the water magician. People are beginning to have the English translations of his work. Henry Fonda was another one of our heroes, and all of these men were getting the importance of the vortex at the same time, and that geometry influences what happens to the medium and the molecules that are within that geometry. Now, vortex technology a vortex is a polarized motion body. A polarized motion body. It has its own characteristics, and we observed those characteristics in air and water and started engineering after them. And we found that there are two forces there's one that creates the centripetal force, which is a curved spiral force of the universe, which brings matter together from the void, from the ether, from the cathode plane, and compresses it toward the solid particles, atoms that we call mass. No matter how many times you break those atoms apart and find new little particles, they're all little spinning vortexes. It has certain characteristics of polarity within it. It has a base, which is the negative pole, and a positive apex pole. And I say positive because it is the gathering pole, which increases positive potential and density. And the dissipating and disintegrating forces of less potential are moving in the opposite direction at the same time towards the base. So you can engineer and manipulate these two forces and control the poles with a four-way polarity control. The centripetal force, like I said, is a life-giving force, and it has certain curvatures of nature, like the egg shape, like a seashell, like the spiral movement in our galaxies, that are supporting life. They're focusing life. They're causing induction. They're causing a biological synthesis. They're causing amalgamation. They're causing growth. And the centrifugal force is the one that, after matter has been formed and it begins to dissipate back into space, and we could observe that, we started using entropy. We started using that force more than the constructive force. And one of the questions was, in Russell's books, was, okay, the apple got up there and Newton saw it fall, and we started making observations of that half of the cycle. But what about the creation cycle? Did anybody go after that? What about that which put those atoms together? So that's what we started copying. It's implosion, it's a fusion practice, which is a little bit iffy. But the other characteristics of the vortex, many more characteristics, boundary layers, cell walls in between, all kind of characteristics that we learned about to copy or engineer with, actually. Okay, so the first set of devices, we started noticing there were benefits right away if we started using these centripetal vortex motions and trying to guide them, making a form that will move the medium of water and air, basically, particularly organic matter. You will keep that organic matter in a quality state. They have a metabolism of life, and they have a range that they can move in. They need motion, and they need a constant input. They need an entrainment. They have boundary layer walls they set up. They have a density separation that occurs. We've been able to tap each of those things and make them useful. The boundary layer, perhaps you're familiar with that. Tesla's pumps and turbines were introduced by Mr. Jake Purcell years ago, and today a company called Disk Flow still makes one of the boundary layer pumps. But each of these eliminate the resistance. You can never do away with the resistance, exactly. You can utilize it. It's a two-way universe. It's always there. Say boundary layer was considered a problem constantly. In aerodynamics, it is the viscosity of the fluid makes it stick to a solid surface moving through it so that it will not molecularly shear apart. Well, that was a problem for aerodynamics. If you could remove that boundary layer resistance, they called it, you could fly 40 times faster with the same amount of fuel. These kind of principles, instead of being called the problem, we've taken them and made them useful. Several of them. There always is an opposite, and many times science just wanted to do away with that one. Even steam technology. They try to move things in a straight line, and hydrologists have the same problem. If you try to move something in a straight line, you get resistance, the square of the velocity. Now with our twister pipes is what we came into, copying the form of the roll of the vortex. It's a small tornado. It's the bathtub drain. There's the two forces, the diagram. I'm getting ahead of my pictures. There you can see the centripetal force goes towards the center, the centrifugal is towards the periphery and the outside in the opposite direction, and that makes layers. That makes the layers. Whenever you have two forces coming together, they make a standing resistance wave, and we've worked with that. So our twister pipes were based after Schauberger's stories. Perhaps you've heard them. He was the water master, and he started copying forms of nature. He took the kudzu horn, antelope horn out of Europe, and he started making a pipe in that spiral form. So eventually came up with this formula, the indented egg, and we cut thousands and thousands of pieces of little 1/8-inch phenolic, and we called them little ears of little men, and we put them on a common axis and rotated them around at a certain frequency to copy a column of water that we measured just from our taps, 30 psi. We strobed it, we timed it, and measured a foot of that. And we're going to make a pipe like that. So we learned how to make the core, then we learned how to cast the pipes, and then took those pipes and put them onto rotors, put them around conical rotors like this one here, and tried many, many types. In our booklet, twister pipes and turbines give funny stories and show a lot of pictures of the turbines that we tried. We blew up a few. Our laboratory was very limited. We had to cooperate with Jake Purcell because he had been doing the Tesla turbines for years, so he had a pit. So we took him some of our turbines after we blew up two, blew the windows out of our shop and a hole through the door. He said, we need a little help, professional help on this. But after working with these pipes, here's the two types of pipes we made. These are the cores, of course. The ones on the left are the pipes that can replace our straight cylindrical pipes that we pipe our water and our gas and everything in. If we incorporated the twist that throws a centripetal predominance of the motion, like Schauberger predicts, we will do away with resistance. We will do away with heat against the walls of the pipe. We will have more velocity. We have molecular stability instead of the disintegration, the oxidation, and the rust that encroaches most pipes and causes a lot of trouble. Well, this could transport water from a spring or from a good source to your home without deteriorating the water. We will be delivering the electrical force in the water that came out of the spring. That was one application. The other type of pipe that Schauberger made was the tapered conical pipe. And those were the ones that we put around the turbine rotors. Here's a couple of the turbines. There's the formation of the rotor. We did conical ones, we did flat ones, and used both forces. It was great fun. This was the final turbine that came out of the work. It was a copy of Schauberger's home generator, and we got to run it long enough to prove that we could have a reduction of input power and an improvement in the quality of water. Unfortunately, it also gave to centrifugal motion, and it didn't run very long, but just long enough to say, yes, there's value in this research. We just need money, lots of money. So we wanted to have, of course, a VTOL spacecraft, like the Schauberger stories, but we didn't get that far. One of the applications, though, we took was the bladeless pump, Tesla's bladeless pump, and it works with the boundary layer principle, like I said. It has no impellers, no vanes. It has marvelous three-phase capacity. It can pump a solid, a liquid, and a gas at the same time. There's no impingement upon any surface of the pump. There's no cavitation to eat the metal away. because there's no pressure fluctuations that happen. The water is moved in its natural form, in a spiral movement constantly. And it's using the boundary layer, the tendency of the water to stick to that surface of the blades on both sides, and moves it outward in a spiral path and accelerates because of the spiral path. You're putting energy into the medium. So we could cut the horsepower in half and pump 3 times as much. It's that type of efficiency. Some of the things that have been pumped with, you wouldn't believe the things that have been pumped. Live cabbages, according to the size of the distance of the disc. What came to us, we got an offer from people doing fish farming, inland fish farming. And they heard about that it would pump materials without any damage, and it was perfect for fish farming because it will not rupture the cells. Human blood has even been pumped. It's the only pump in the world that's ever pumped human blood without breaking any of the cellular membranes. So fish farming industry is a growing industry out of necessity. Our waters are in trouble. Our oceans are in trouble. The fishing industry is having to put limitations on the species to prevent collapse of the species. And we made an acrylic fish pump on purpose with one disc, and so you could see into it. And we took some little tropical fish with very fancy veils and tails to the Icelandic Fisheries Conference. And we pumped those little fish through there for 5 days, for 8 hours a day, with no harm to the fish, same ones. And the fisherman would stand there and say, "You can't do that. You know, you can't do that." And they'd watch that little fish go around. But eventually, fish farming industry did listen, and we got into they need pumps. They need pumps for their water circulation. They need pumps for mixing their food. They have to oxygenate the water periodically, and the Vortex does that the best. They need sorting of the fish. Many things like shrimp eat their young. They're carnivorous. You have to sort them by size. And inland villages that are 100 miles from any river or water can give the village staple food, trout and catfish, and they can grow high commercial products like eggs and minnows and shrimp and all those kind of things, and then pump them with the pump into the tank or the processing tank. Do away with conveyor belts. You go straight into the tank, pump all your shrimp, water, and everything into the ice in the truck that's going to transport it. There you are, live shrimp on ice. Just drain the water out. Well, here's one of the pumps that was developed in Australia, and it has a changeable rotor, the Vortex rotor. It has those discs in that pointed part. Here's another one. It's on a tractor PTO, and it was at Lake McDonald, and it was a fish pump, and they were proving the principle. You could put anything from a 6-inch fingerling to a 10-inch broad salmon through the same pump, and they'd come out the discharge hose unharmed. And in the industry, of course, they always had to get rid of waste. So here's another vortex. We took the vortex principle that if there is a stirring vortex in that vat of water, it's layered. And it's layered with the density coming towards the center and the apex. You can find it there. You can take it off. You can extract the density of particles right there. And so we had a electric motor at the top and a shaft that was slitted that rotated, and a boundary layer disc on the bottom which catches the water and starts the whole vortex motion. And then a pump at the bottom to pump off the solid particles. Then it was taken to another tank and re-oxygenated to put back in the system, or maybe vitamins were added. Water storage is a big problem of our civilization, and right now, most of the time, we put it above ground, up on legs in a metal container in the sun, in the heat. And Victor Schauberger always insisted that water needed to be at a cool temperature to be preserved, and that it needs to have some form of motion. Stagnant water, standing, tends to separate into layers, lose its oxygen, and settle out as silt on the bottom. And you have a lot of mucky bottom and deoxygenated water that is useless. And before the city puts it into the municipal water system, they have to treat it over and over again. So the water storage underground will approximate this plus 4 degrees centigrade that Schauberger wanted. And at the bottom, this one has a stirrer and a pipe that you can go off. That's a 7,000 drawing. We had a 3,700 agricultural water storage tank built like this. And with a stirrer in the bottom, just like eggs in nature, there's a polarity set up. There's a longitudinal axis of rotation that amalgamates. And there's a video on YouTube today where you can watch a chicken egg in 21 days being hatched, and you will see right around that central axis is where the amalgamation begins. And you will see the spine of that little chick come, and then both sets of his parts, and they've got a chicken in 21 days. But that's what keeps the water alive in a storage unit like this. It's known fact that if you keep milk in a square container, it will deteriorate faster than in a round. And things have been seen, but commercialization has not allowed. We took that water life, the need of water, we took Victor Schauberger's explanation that water is the firstborn. It is the first live element in our universe, and it has a metabolism. There's certain needs the water has. It needs to be moving in this vortex motion constantly. If you're just forcing it down a straight pipe and subjecting it to all that resistance and heat, you are molecularly disintegrating the water. And then you have, in 24 hours, if you're storing that dead water, you get pathogenic bacteria growth, and they have to treat it before they even move it again. Well, Victor Schauberger had he had a patent on a water ennobler device, he called, that he explained how that where water gets its charge of electrical charge is underground. It has to go into the earth, get in touch with carbon elements in the earth, and take on its electrical potential so that it can levitate, actually, as an artesian spring. And he has a full explanation of that after studying it for years and years. So we copied it. We took made a porcelain egg shaped. We used to demonstrate with the open glass ones, and we broke it, of course, going to Hawaii, but we could see the vortex happening in there. Okay, so the device takes water, sterilized water, puts it into the egg shape, has a stirrer in the bottom, it's hermetically sealed. We have carbon dioxide on top and a few trace minerals according to the formula or recipe that Victor Schauberger gave us after measuring all the streams, the mountain streams. So he gave suggestions, how much calcium, how much this. And we put those minerals in, put it in the refrigerated temperature, and brought it to a plus 4 degrees while it was in darkness. And a vacuum of a minus 10 occurs in about 20 minutes, and this vacuum synthesis has linked the carbon dioxide to the water. It's not anything like that which is pressured in the carbon drinks of today, the sodas, and whenever you drink it, as soon as you open it, it's trying to escape, and it causes big belches and burps, whenever you drink it. With the vortex, things are linked very finely very tightly. And the shelf life of the emulsions and the chemical synthesis that it's been used for is longer. They're stable. The emulsions and the mixtures are stable. So vortex principles of efficiency to move mass the way nature does. This is just a copy of a cone. It's using the boundary layer principle again. It rotates in the water. It was introduced to city water waste pools in Edmonton, Australia. They went for it. They said, yes, makes sense, we'll try it. And the process of aeration that they were doing by liquid oxygen at one time took 60 days to revitalize some of their waste pools. With this device, it took 10. That's how efficiently it links. They would pour some chemicals into the center of the vortex, and that would help the mixing. And then, of course, it's drawing in oxygen. It was just a prototype, but it's still working today. Here's the construction in the lab and setting it in the lake. And then back at the city waterworks, the municipal building, they had to mix. They mixed concentrates before they were going to pour them into the larger bodies of water. So that's what this is, parabolic dish. It's made where the top has a hole in it. They can add the chemicals there. And the bottom has a boundary pump again, which keeps that vortex stirring, going, and mixes. And the bottom can be taken off as a parabolic stirrer and used instead of that vortex-shaped one. And it makes a very deep-throated vortex, has a strong pole. Another quandary of our environmental situation today is the burning of fossil fuels. So we were always looking for a way to have fuel-less engines. For instance, fish move and do miraculous things. Birds do also. They don't use an extra engine and bring along something to burn to have their power. They know the inner laws of their mediums. That's what they use. They make that their motive force. We say, why can't we do that? Let's copy nature. And it's a propellerless shape of a fish that was actually Victor Schauberger first noticed a trout up in the mountains, and the story goes he jumped over a little creek and that trout went upstream with lightning speed, and he was at an altitude and above a 180-foot waterfall, and he said, how did that fish get up here? It was the waterfalls diffusing the medium, which makes mechanical thrust almost impossible. What is that fish doing? So after years and years of observing this type of phenomena, which science had no answer for, he came up with a term he called biomagnetic axial force, which is the force acting from the center of a moving body of water or air. In every river that we see, there's two currents. There's a current from both shores that are coming together. They amble on down according to gravity fall. But they constantly need to twist. Now, this is in every healthy mountain stream that hadn't been irrigated or put into a straight channel. You can see that. And it'll go from one bank and it'll carve its bank that which it needs. And instead of spreading all the way out and losing a lot of deposits, the cities have to take it off and get rid of the gravel constantly. If you leave that vortex to move and flow like that, it will carry that gravel with it in the center because the density layers. And so this has been done over in New Zealand by a group that works with the vortex. They got a state contract to work on the ditches right before a bridge. They put in some Vortexian inward-moving fins, and it kept the water, whenever there was a lot of rain, from eating the cement off the side of the bridges because it pushed it to the middle. It'd go through the culvert just fine. And on turning the water, a large force of water, if you use a vortex, you don't have the 90-degree resistance and the splash over and all the mess that was usually occurring. Well, they proved that to the state of New Zealand that we should use some of these Schauberger things. Well, so we tried to copy the fish motor. Here's our couple of the models. It has, first let's go into fish propulsion, what we're copying. Fish will stand for hours in a stream, a fast-moving stream. And they open their mouth and they create in front of them a vortex which they are pulled into. And they push the water through their gills, which compresses the water, takes the oxygen out. And the gills are very much like those discs on the pumps. And it compresses the water. And then it pushes it along the backside of the fish, which is conical shape, and it tends to make this vortex, and it wedges the fish forward. Interesting observation is that the shape makes the difference. The shape makes the difference in the type of result that you get. And so egg-shaped, curve-shaped, again, we are copying that. And here's the principle. You got the suction in the front, you got the wedge in the back, you have no resistance. The fish also uses its scales because when water leaves the fish, it's decompressed slightly or compressed slightly, and so it's a different temperature and a different density than the surrounding water. It wants to stick. It wants to keep the fish and hold the fish. Well, they raise their scales a little bit, and they make 1,000 little eddy, little whirlpools, and they use the boundary layer to free themselves from the viscosity. And you can see them regulating their scales. A dolphin and a shark use wrinkles on their skin, but that will let them slip through quickly. Well, here we are. We've got the principle. Okay. At the front, there is a spiral-guided conical movement. It moves the water, the medium of water or air, into onto the turbine. And this is a Tesla turbo pump. It radially spirals outward towards, and then is, it's given off into that shroud. Okay, where's my little laser pointer? That's what I need. There we go. Okay, the turbine, the Tesla pump turbo thing, is in the front here where the water goes in, and there's a shroud. This is from Kawanda's work. There's a shroud here to help protect the egg-shaped body or conical-shaped body of the fish motor. And then the water is spiraled around on that pump, pushed up against the shroud, and there's a slit at the back. A ring slit all the way around where the water is, it's kind of like the fish's gills expelling the water there. And also we use the Kawanda step because water has the tendency to stick to the edge of the glass when you're pouring it. Well, that's the viscosity of the medium, so we use that also. Kawanda used to use that. He was one of the early father of aircraft design. And so that step, as soon as the water comes out, goes, sucks it down and guides it towards the back of the egg shape. It also entrains from the outside. It adds energy at that point. There's a step up of speed and energy. And so it pushes and pulls. We've got the two-way principle acting in the same way, same direction. This could replace a lot of our fueled engines, our boat motors and our jet engines, and we could do away with burning fossil fuels by using our mediums as the fuel. And working with the spiral path, keeping them in that spiral path, is not destroying them, it is enhancing the quality. After you've used it, you have a medium that's worth more than when you started. So that's two advantages. But we ran this round to round in the fish tank and had counterweights, and we could notice on the second unit, when we did incorporate the ripples to break the boundary layer stickiness of it, that there was a 17% efficiency increase in the speed. Anyway, that was the hope. It could be introduced. New kinds of motors, fuelless, practically fuelless motor. At least we can save fuel. It needs to be developed. It needs to be run. And tested. And our realization is we're polluting the water and the air at a dangerous rate. And obviously you can know that. It's in the news today. We're in trouble. How much water can we mess with? How much water can we mess up? If this block was the world water supply, 97.2% would be ocean, which is salty, and we haven't perfected desalination. There's several methods on the work right now, but we better hurry up. And then the next little block there would be the ice caps and the glaciers, and they're melting, by the way. The next percentage block there would be the soil and groundwater, that which we might pump up in our wells. And the next block would be our surface water, our reservoirs, our lakes. That last little block, and barely a dot over there, is atmospheric water. Now, how much does it take to contaminate that water with diesel water? Only 1 part diesel oil per 10, I think that's 1 million parts of water will ruin it without where it's not drinkable. It's unfit for human consumption. So we better think about what we're polluting, not reclaiming, 1 gram of diesel oil contaminates 1 cubic meter of water to make it unfit to drink. 10 liters of diesel oil contaminates 10,000 cubic meters of water. That's the yearly rainfall of a Canadian forest or an Austrian forest. So we're contaminating faster than it can be cleaned out. How much oxygen are we dirtying up? How much oxygen do we have? How much oxygen can we make? A human being in the United States uses approximately 6 tons of oxygen to have our cars, our heating and cooling devices, and all of our appliances that allow us the quality of life we have today. A human being only breathes 1/3 of a ton. So the other 5.5 tons that we're using per person in the U.S. every year, we're wasting on our luxuries. Maybe not wasting, but we've got to find a new way to fuel those things because we're using our oxygen. And we're not replacing it, we're cutting forests as fast as we can, unfortunately. So the burning process of 10 liters, approximately 2 gallons of gasoline, or 10 liters of heating oil, or 10 kilograms of coal, will consume 23 kilograms of oxygen. Now that's enough oxygen to supply a human being for 3 weeks. In a year, an adult uses 1/3 of a ton of oxygen. Have you ever considered that that'd be a possible oxygen shortage? We know there's an atmosphere pollution. You can look at the news today and see the cities over in China and Mexico City, and people are wearing their mask, and the diesel particulate is settling out. I lived in Mexico for a while, for 2 years. They run so many diesel engines, you can see it in the air, and every day little black soot falls on everything you own. So we're breathing that. It's not good for us. We are putting pollutants in our water and air. Well, yes, we may suffer from a fire catastrophe yet, because the Ohio and Mississippi River have already been on fire from all the pollutants that are in them. If we put oily carbon substance and our petrochemicals and all of our fuels we're setting up for fire. It's going to get overloaded, a little bit of spark. We're going to have fire in the air. That's a biblical prophecy. And we can see it coming. It's already in the water. So we advocate planting trees, stop cutting trees, or at least replace them, and Schauberger gave us a lot of information about that. An oak tree with its broad leaves, for instance, processes oxygen, gives off oxygen and water. And a 100-year-old oak tree, which would contain approximately 2,500 kilograms of pure carbon, has, during its lifetime, processed enough carbon dioxide through photosynthesis and provided water and provided 660 kilograms of oxygen for man or animal. That tree provided 20 years of breathing oxygen for a citizen. Now, the usage of 100 liters of gasoline consumes 230 kilograms of oxygen for its combustion. So assuming a car is getting 26 miles to the gallon of gasoline, after 18,500 miles of travel, you've consumed the complete 100-year oxygen production of that tree. We can burn it up, or we can live longer. So I have some figures on how many trees you and your family of 4 might need to plant to secure your oxygen for your lifetime, and how many trees, acres of trees, we need to plant around our power plants, existing power plants, to offset their emissions. In early 80s, there was one company that set the precedent and said, well, yeah, we'll plant 10 million trees down in Guatemala. Well, that's about as far as they went, too. Nobody has followed suit. We will never meet our Paris agreements or our environmental agreements unless we start. We're already behind. We're having an oxygen depletion problem now, and it's accelerating. Another aspect of the vortex is resonance. We started working with one of Tesla's devices, the sonic oscillators. He claimed this was his most fascinating patent, which was never developed. Well, we took that patent, we started building them. That's the little oscillator that he calls the New York earthquake with. We built large Tesla telegeodynamics, 200-pound units, and coupled them to the bedrock of the Rio Grande and a couple other places up and down the West Coast. And our hope was to go for this global communication system that he advocated. You had an oscillator at one end, you had sister units all over the world, and you create a system of standing waves within the Earth itself, within the sphere, within the globe. There's advantages to it being spherical. And then that was used as a carrier wave for communication and electricity. And he hoped you could just plug in anywhere in the world your receiver and make use of free electricity. Of course, you know what the system thought about that. We better hush this man now. So we copied the little 4-inch oscillator, took it to the Tesla conference in '84, I think, and showed it, and received a real nice opportunity of finance and funding for several years to build quite a few of these. And when it came time to go global, our funder said, well, you know, this is a big thing. We need a geophysical team to cooperate all over the world, and I just can't fund that. So there they sit. Well, we learned enough to take and put other applications on this device. We built little motors. The beauty of this, and Tesla's invention, was that it is frictionless. It's a piston with an air cushion on both ends, and the import and the export real close together in the center, and it takes very little impulse to get these pistons to go. Well, you can run it at a very high frequency. It delivers a tremendous amount of power. It will go into resonance. If you put it on a cavity, it will cause resonance in that cavity. Some people objected because it's dangerous as a weapon if it could be used that way. But there are positive uses too. We had also worked with Schauberger and heard about his oily emulsion, which we were making with our hermetically sealed vortex spring there. It was coming out that the transmutation process that happens in a vortex was going on. The hydrogen was turning into carbon and increasing the carbon content of the water so much that it's oily. It's an oily emulsion, and it will fire under just a little pressure. So we were hoping to put it in these machines, and there you've got a new fuel and a new device for motive power. That's still to be proven and developed. The good news about all these devices that I'm showing you, over the years, I have kept our shop notes, our blueprints, our engineering drawings, and all the pictures of the development. And I finally got them into digital format, and I'm offering them as booklets for very little price. If you want to take that, get that, take it to your lab, take it to your village, duplicate it, help us take the research further. From 1 to 5 of all of these things have been built. Well, we need a lot of them to prove the principle. But feel free to do that. I will act as consultant as far as I know. And I believe that some of the inventors here, the researchers, could duplicate any of these devices. And that's making them public. Since I'm showing them today, don't worry about patents. Don't worry about the patents. We need to get this out. We don't have time to fight over patents, and you waste your $50,000 doing it anyway. Sorry. The big company will come and take it anyway. But I understand the need that some people think. But we just gave up on that and said, this is a world benefit thing. We need to get it out to the world. We're not interested in just making money with it. Resonance. Perhaps you've heard of resonance in music in an auditorium. What is resonance? It's when the two opposite forces come together equally. They penetrate and go into each other. They create this zone of a standing wave, and that is where the third free tachyon particle can come in, for instance. That's what gives quality to sound. That's what gives, it's the right combination point that reach the highest quality without attenuation. Perhaps you've heard about the German World War II society called the Bell Society. Well, part of their work, they discovered the resonance of the bell, and it's an ancient usage anyway. And this little unit right here is a bell within a bell. It's an induction heater. that work 7 times more efficient than the heaters that are in our water heaters and our steam generators today. It's 7 times quicker and more efficient. Very simple. We've got a bell within a bell. And they're hooked, each one is hooked to a power source separately from the other. And they emit, of course they have a magnetic field as soon as you put electricity on both of them. And they overlap. Their field lines are overlapping and they're creating a standing wave pattern in between the cups. And since it's a bell shape and those patterns are focused, they're guided again, the shape matters. They're focused to a center point and they inductively increase themselves 7 times. You can, let's see, what did we get? We had 3 liters of water will boil at 97 degrees in 3 minutes. A steam boiler could be heated this way, and the wave that is the induction wave is an electroacoustic phenomena. Now that causes molecular excitation in that standing wave part, and the molecules produce thermal energy. We could use this to produce thermal energy because most of our devices still run on steam. We think we're real modern, but they still use heat and steam to make most of our power. So we could do it electroacoustically here without burning fossil fuels. Very efficient. I guess I've gone through things pretty quickly. But our whole point was to get new technology out there based on life-giving motions. Let's treat our mediums of carbon like they're alive. We will keep them longer. We will increase our own health. We can fix it. We can give the powers that be and the technologies that are going, hand them something. Give them an alternative, Don't just gripe and gripe. You've messed up the world. Give them, our point was you've got to give them some alternative. So we tried to do that. We took the fish pump to the Washington Fisheries Commissions, though. Here's the resistance. They've been trying to solve the problem of fish getting back to their breeding ground and getting through dams and turbines, and so they build fish ladders. Well, they're very inefficient. Less and less fish are getting back to the breeding grounds. That's one thing, the species is in danger because of that reason. So that particular pump, Tesla pump, they could have turbines and pumps. The fish could go right through them, no problem. And we took it to the Washington Fisheries Commission. We got to the head man. He was convinced. But, he said, my department has 37 people working in it. We've been working for 18 years on this problem. If we solved it next week, all these people would be out of work. I can't do this. Well, that's a valid point, but somewhere we've got to start making the transition for the sake of the bigger whole. So let's fix it. Let's become a part of the solution. I want to encourage, if we could put some of these devices in the water bodies around the world, in your village, donate it to the park, then you will be cooling the environment. We're having our global heating right now because we've been using the centrifugal force, having resistance, causing all the heat. We're adding to our own dilemma. But if we started using these devices, we could cool our mediums again. We could cool the ocean. The lakes around a nuclear power plant that have been put there, and streams have been backed up for miles, sometimes 40 miles, to provide enough cooling water for that power plant. Well, the temperature of the water in a couple of years goes up 4 degrees. The fish species have to change totally. So we could reverse some of that. We don't have to destroy our mediums, and we definitely believe in that. All we did was prove some points. Now y'all help us take it further. Take it further. Let's save our planet. Thank you.
Thank you very much, Rhetta Jacobson.
Thank you.
Do we have time for questions and answers?
Oh, yes, any questions? Sorry. Nope.
Oh, here we go.
What is the availability of the twisted pipes?
They need to be, we need to find a manufacturer that already has an extrusion process going on, for instance. Alter that machine just a little bit and crank out these pipes in so many links. And install them. Install them from your well to your barn. Give it a chance. You'll see the quality of the water, the delivery of more water. But nobody's making them. Nobody's manufacturing today.
The drawings, though, are available.
The drawings are available, yes. And our first set of pipe tests done in laboratory other than their own, because you always need that. You can fool yourself. You'll believe in your thing so much, but you need a second or third opinion. All inventors need that. So anyway,
Can you
we
tell
have
us-
those tests,
can
and
you
it
tell us
shows.
the website?
Pardon?
What is the website from which these are available?
It's working right now. Remu from the University of Science and Philosophy is helping me build one. But I have my catalogs here and my addresses where you can, I have email. But I'm just getting back into the digital world. Yes, we have the test done from these devices, from objective devices. And I put them in the booklets. You can see that these pipes actually produce suction. They said, it just sucked all the fluid right out of the other device. I said, yeah, that's what it's supposed to do. We failed the test, they said. We just ruined our testing devices because we sucked all the fluid out of it. No, that's positive. That means there's suction. And of course, we had other effects of it show up too, but that was our first test. Anyway, any more questions?
Yes. I don't know if I missed it, but have you noticed any difference between clockwise rotation in the water and counterclockwise rotation in your pipes or water or your machines?
Not for this purpose, no. That's a polarity dilemma that people observe, but that's really not an influence. What is happening is the inward and outward, the centripetal, the centrifugal makes the difference in that vortex. That's where you regulate it. Those two forces are more important than clockwise or counterclockwise. You can do it with either one. The phenomena that you're seeing is a polarity thing. You can turn, say take two cones, draw a spiral from the center going the same way on those cones to the points, and look at one end. It'll be going clockwise. Turn that same set around. Look at the other end. It will appear to be counterclockwise. It's kind of a trick of polarity that occurs. And it's not something to get as a cause. It's not a cause.
Interesting, thanks.
Uh-huh. Anything else about the
question,
device?
if I may, on that. So this pipe, it looks like there was an insert. You take that spiral device and you insert it into a pipe. Is that correct, or is it?
What you were looking at here were the cores.
Right. So it's a
Yeah.
core. Now, a question. A couple questions. One is, to get the benefit, do you have to have that core run the entire length of the pipe, or can you just have it at its source or either at its use point, and can it still be effective?
That's a good point, because in Europe right now, they are finding out that just vortexing their industrial water just for a few minutes before putting it through their pipes helps. So it may be a matter of time that water has memory. They've proved that. Water can carry that memory. It can be structured. It can be aligned. It can remember its own quality of health and tension. And they're taking a little bit of water that's been vortexed and putting it into a bigger body of water, and reminds the water molecules of what they're about. And it can purify just from that. They regain their water memory, which is the vortex movement.
Yeah, what I usually say is if somebody can kind of sing and somebody else can really sing, well, if you put them together, it really helps this person carry the tune. So they can remember to stay in pitch because they have something to hold them there.
That's interesting.
Anyway,
analogy.
but the other thing I wanted to ask too is, so let's say, okay, you got a pipe and you're delivering it to some distance, and of course there's some bends and twists. Do the elbows in the pipe degrade or ruin, and how many of those twists can it survive for a certain length of core spiral?
That needs to be worked out. Of course, it's going to be a relationship between length, volume, and the pitch. And so we had to work with that and try to find the right one for 3 feet. That's what we worked with and tested with. And those formulas need to be worked out. I mean, if you're moving large city water, you know, how many turns do you need? Victor Schauberger gives in his patents indications of those. You know, the placement of the fins. Have you seen his patents?
Yeah, I've seen a couple of them and read some of his books. It's pretty interesting.
I mean, there's a distance, there's a ratio of how much volume and how fast you want to go, what's your velocity. So we had to work with that. And
then when you have a turn, let's say you have an elbow, a 90-degree elbow, is there some kind of
don't do a 90-degree.
device
That's the whole point. Don't do 90 degrees.
Right, it kills it, right? But so let's say there are some twists or something. At what deflection point can you go without degrading the quality of the water?
What deflection point?
Well, if we know a 90-degree will injure the water, then how far can you bend the water without any kind of injury?
Well, with this vortex movement,
Correct.
you can pump it around the world, keep it alive.
So in other words, after each bend or after each twist, you just have another core.
Another factor, and if it's a system, you'll have to have injection points for entrainment of air periodically, like Schauberger did in his log flumes.
Mm-hmm.
He would inject the cold water and keep that temperature just right. Probably need something like that, you know. What's happening is that centripetal motion, that egg indent, makes the Bernoulli principle constantly. You've got the suction going down. And we don't meet up with resistance. It doesn't get stuck. It doesn't stop. It has a longitudinal force. A vortex has been proven to have a power towards the apex. The density goes there and the potential goes there. But up the center is a hollow
channel of energy.
Upward draft. That's the gravitational center that's within every vortex movement.
That's where you get the levitation.
And there's an
forces.
updraft. That's Schauberger's bioaxial levitating force. And we could see that. We looked at hundreds and hours of vortex, inked them, have a lot of photographs of all of that. But you can see the movement. And if it's in a hermetically sealed container, that updraft will rejoin and recharge the water, and the quality of the water gets better and better and better. Better and better. And it comes towards heavy water, which they don't want you to play with.
Excellent. Thank you for your presentation.
Mm-hmm. Thank y'all again. Oh, here comes somebody else.
Hi, Matt Presti, President of the University of Science and Philosophy. Good presentation, Rhetta.
Thank you, Matt.
Thank you for being here. Rhetta is a consultant to the Science and Research Committee of the university. I just wanted to make a point about something she said in one of the many meetings we've had by Skype, which actually directed the course of our group. And that comment was, you know, a lot of us start in the movement for energy, cleaner energy production, in a way to try to just displace the powers that never were, as I like to call them, that think they control everything and limit human consciousness to more of a lower state. We started out trying to displace them and put an end to them overnight, instantly. And she advised the committee it would be best to integrate and update the existing technology as opposed to just cutting it out completely overnight, because you're talking about the collapse of civilization. Hundreds of millions of people around the world would suddenly be out of work, and that is not a good service to give to your fellow humans. So she introduced the concept of bridging through technology alteration, in other words, transmutation of existing technology through small steps over a period of time as opposed to an overnight solution. So that wisdom was something that kind of directed our science and research into a usable bridge of taking civilization across the bridge without hurting it or, putting millions of people out of work again. I just wanted to say, as president, I'm very grateful for your involvement with our committee, and thank you for that suggestion, because over time, we want to see all of civilization cross the bridge into new uses of technology, and upgrading our existing technology is the way to do that, as opposed to making it totally obsolete overnight. It's a process, just like nature doesn't throw things away overnight. She makes things happen over a period of time and years that is deliberate and very poignant or pointed to a final goal. So thank you very much, Rhetta.
The way it was told to me by my mentor, what he's saying, he told me straight out. He said, Rhetta, you can't meet them head on. You can't go in there and be absolute. Hey, this is such a great idea. Let's throw everything off the shelf. We're ready. We got new stuff now. He said it's a lot easier to walk beside the bull and turn it gently than to meet it head on. So that was my personal spiritual learning. Okay. I'm
Thank
done.
you very much, Rhetta
Thank you.
Jacobson. Ladies and gentlemen, we'll